Hello everyone, I am Sneha Maganahalli. I am going to demonstrate the buffer overflow concepts. So let's go over the challenge 1.
This is a C program called allallowed.c, and allallowed is the corresponding binary. I will use GDB to inject the shellcode into it. By using the buffer overflow, I will override the return address with the start address of the buffer which contains the shellcode. So I am creating random pattern of 150 characters here, and I will give it as an input, and it will result in the buffer overflow. So now I give here as an input. So once I do pattern search, I will get the offset. So that is the offset of the return address. So here you can see the offset comes as 104. Here you can see that the return address is overwritten with the pattern. Since the pattern is some junk value, it results in segmentation fault. You can see that the register has this pattern. So now going to understanding the offsets. So we got the pattern match at 104, and I have 30 plus 27 plus 44, that is 104, and another plus 8 I will do to get 112. So why this plus 8 is, this is the return address. So after the offset we are going to keep the return address. So first 30 is the no op, 27 is the shell code, and 44 whatever it is the continuous character CA. Okay, you can keep any other characters, no matter. So what happens when the no op comes, the CPU don't do anything, it just go on executing. Okay, so here I am executing the program to get the buffer initial start address. So this same start address I am keeping in this 8 bytes. So total, this is the padding. This padding I am redirecting into a file 1. So now if I open the file 1, so our program is taking two things as an input: the size of the padding and the complete padding. So the complete padding was in the below line, the above line I have kept as 112. So now I will execute the program, and now I got the shell. So I can do now ls or anything, any shell commands, it's going to work.
Let's go over the challenge 2. So the challenge 2 is, in the shellcode there should be no null characters. So why there should be no null characters? This is because suppose we want to hack string copy. String copy, at the end it will check there is any null character or not. So to hack these functions, we ensure that there should be no null characters in our hacking code.
No nullbyte.c is the .c file. The binary also has the same name. So I am compiling it now. So I have given various options to disable the protection. The main options which are needed are pi, exec stack, and no relro and -g. Pi is to make position independent executable. Exec stack is to make the stack executable. No relro is for no relocation. -g is to add all the debug symbols and for the GDB. So I'll be repeating the same things again which we have repeated for the challenge 1. So here we create a pattern of 150 bytes and we give it as an input. So once we give it, we are going to get the seg fault, and when we do pattern search we get the pattern as 120. So the seg fault, we know it's obvious because the return address has been overwritten with the junk values. Here also we can see all the registers, whatever contents it has. So now to understand the padding, it is 30 plus 34 plus 56 is equal to 120 plus 8 is for the return address. So first 30 is no op and 34 is the shellcode, 56 is the series of characters CA, or you can keep any other characters, and the last plus 8 is for return address. So we will copy this command and we will execute now. We will redirect it to a file, and this file will be read when we execute the actual program. So once we execute the actual program, we will get the shell. So let's see it now. So here we redirected into a file. So in the first line, I'm keeping how many characters are needed for the padding, that is total 128. In the below line, we had the padding. So now we execute it. So we got the shell, we can execute anything, ls, who am I, id, anything.
So let's go over the challenge 3. So this program is taking only 90 characters, means if you give 100, it is going to reject. So after that, whatever characters we are giving, that should be in printable. Non-printable characters, it is not taking. So let's see how we will hack this.
Printable only hacker function.c is the C file, and the binary also have the same name. I am compiling it with the same options, and now I am executing it. Suppose if I give 90 bytes, it will take. Suppose if I give 91 or 100, it is not taking, because the maximum length which is accepted by this program is 90 bytes. Because in the program they are checking whether the length variable is greater than 90. If it is greater than 90, they are rejecting it, but they're not checking whether it is smaller than 0. So I can give -1 and hack it. So I will give -1 and hack it and use it for buffer overflow. So here I am creating a pattern of 150 bytes using the pattern create, and I'll be following the same steps with whatever I have followed in the previous challenge. So we will get the segmentation for this is because the return address will be overwritten by this junk pattern, and now I can see the offset will be present at 120. 120 bytes is the offset where the return address will be present. So I have to keep 120 plus return address. So 120, yes, I am going to keep A because A is a printable character. You can keep any other printable character because this program is accepting only the printable character. So the return address will be the hacker code address. So hacker underscore code is the function, the hacker function which he wants to execute. So I will get the address of it and I'll keep it here. So now I will execute the program. So before executing, let's see the hacker code. Here I am calling the /bin/sh. I will be invoking the shell. So now I will copy this command and paste here. So in the file 1, we have the payload, and the payload is 128 followed by the return address, that is 120 plus 8 is 128. So now I will execute the program, then it will be hacked. So now I got the shell. I can do anything, whatever we can do in a shell, like ls, copy, move, all the things we can do.
So I'll be discussing one more solution for the challenge 3. So let's go over it.
Proc.c is the C program's name. The binary also has the same name. Shell.c is the hacker C code which he wants to execute. So in this code, he can do any malicious work. Here I am just invoking the shell using exec v system call. Exec underscore shell is the binary of the shell.c. So if you open the program, hacker underscore code is the function. It is the hacker code. Here I will be executing the malicious binary, that is exec underscore shell. So how to calculate the offset and how to execute the program is same as shown in the previous example. So now we will see more about this solution. So why are we having our own hacker binary? This is because the program which we want to hack does not want any printable characters, whereas our hacker binary has the printable characters. So we can think of one more solution, like we can have a shell code as an environment variable, and the value of the shell code will be the complete executable or the binary which we want to execute. So we will keep the address of this environment variable in the return address, and then we can hack. So this is one way of attacking. Finally, the hacker will get access to the shell as shown here.
Thank you for watching the video.